Right, I think we're live. Just wait for that to update. Yes, we are. So, updates. Updates, people. Summer holidays. Yes, they're just about over now, aren't they? Right, yeah. So, I've been printing an additional feature for the jet boat. Um, as I've seemed to have solved all the leak problems now, I've got the motor shaft alignment and everything else working okay. I'll put a separate video up to show you that sailing. Um, but now it's just a matter of knocking out the components for it. This is just a simple, um, what they call a bow plane. You've seen them on the back of most of these speedboats. It's just, as you can see, it's got a small angle here of about, what, 3 degrees, maybe 4 at the most, I would say. Um, Pretty straightforward to clear. Add a fillet, um, and it's about 10, maybe, yeah, 10, 1 centimeter, 10 millimeters across that way, about 2 millimeters thick, and with a fillet added. Let me just rotate that around a bit. Oh, I'd noticed that. Seem to have given myself a fillet on that corner that I wasn't aware of. I had no idea that I'd added that. There you go. That looks a bit better. Must have been adding fillets and it got, so I just selected it and pressed delete. So yeah, there it is. You can either use that box to rotate or you can do a free rotation here. Yeah, just so you can get an idea of what it looks like on all the different axes. And then let's just shut down Cura and go and print this out in 3D. Select it. It's pre-selected for Cura, so we'll say OK. Cura seems to be pretty good at doing difficult materials. I've been using the Prusa slicer for some things, but it seems that when you're printing things like ABS and TPU, Cura seems to have the edge, and I really can't see why Prusa can't do the same. Um, I've had some success with Prusa on certain things. It seems to be, as I've mentioned in previous videos, very good at producing efficient code. But what Cura seems to have is finesse on more complex objects and materials. And I think this is where Ultimaker, because it's updated fairly regularly compared to the Prusa slicer, seems to have the upper hand. Slower to load. Yeah, I mean, Prusa is very fast to load. But in terms of overall, I'm printing out these little things in 0.15 layer height, so I get a really good bond because it's quite thin generally. In fact, it's 1.5 millimeters thick, not 2, because I wanted it to be quite light. I used PLA for the strength. Sorry, not PLA, ABS for the strength. So just wait for that to load. It should be there in a minute. If you want this theme, by the way, it's up on the Microsoft Store. It's called Aquatic Theme, and it's got sounds in it. So when you plug in your USB port and unplug, you get lots of water-like noises. So my son and I find that quite humorous. Anyway, so I digress, but let's have a look at it. There you go. So you can see the fillet. Everything's looking good. So I've got a 0.15 layer height, wall count of 3, top and bottom thickness of 2. What else have I got? Basically, I've selected generic ABS and made that a favorite. So you can come here and where is it under your drop down here? And manage your favorites. So There's an option here, I think, to go and there we are, material. Manage your materials or Control K, and from here you can select your materials, but you can also favorite these, so then they pop up in the drop-down menu, which is quite handy. So I've selected ABS. I'm still using 0.4 nozzle, but I'm using a layer height of 0.15, and because I've selected ABS, it's selecting temperature, which is quite high, which you need for ABS. 240, 110 for the bed. Flow I've left pretty much where it sets it. Speed I've dropped down to 50. I'm using a brim of about 3 and all the usual settings, nothing outstanding. Yeah, so that should print out okay. And yeah, there you have it, ready to go. So these are going to go on the back of the boat. And what they do is they extend the bow wave. So instead of it coming back up behind the boat, because it kind of gets sucked up behind the boat, what it does, it tries to extend the bow plane further out the back, because the suction that comes through the back tends to want to slow the boat down. You probably notice this with a boat as it eases up and comes off the plane, it starts to sink into the water, and then you get this kind of vortices that come around the back. It behaves very much like air. So as soon as you get to a certain speed, the bow tends to initially lift as it planes, and then eventually as the speed gets faster, the nose starts to drop, and the planing starts to move towards the back of the boat as air gets underneath it. And then the nose starts to drop, providing your center of gravity is about midpoint. And what the bow planes do is it extends the bow water that's milling around the back end, and it extends it outwards, and that then gets the boat onto a more stable plane. It seems to stabilize the boat from rocking as well, because the boat tends to rock, especially when it hits waves or undulations in the water. And this, as you get faster, it tends to have this very thin planing area at the back end, just like it does with a windsurf or a surfboard. As soon as you get up to a certain speed on a windsurf, and you can get the nose out of the water and get it planing on the tail end um, of the windsurf. They have all sorts of fancy tails on windsurfs, pintails, pintail wingers. I mean, I used to do a lot of windsurfing, but you get used to being able to control the board and its direction just by your feet and the straps when you're at certain speeds, and the fins. And the bow planes, you can see it coming out the back. It's very, very clear when you're sailing. So what this is trying to do is extend that kind of planing area at the tail end, so that it creates a smoother and more stable sail. I think that's the best way to describe it. So I've added these. Other things I've added is I managed to find some slightly better seal for the lid, because there's a groove in the lid, and there's nothing supplied to um, fill that. So I bought 2 of these little O-rings, and these are 2 mm 96 out of diameter. Ideally, you need even bigger, not thicker, but I would say between 2 and 2.5 millimeters is adequate. I think probably 2.5 millimeter is the ideal width for the O-ring, and then you just slot that around the inside with a bit of super glue. Just make sure you don't stick your fingers to it at the same time like I did. This is the other thing I'd recommend buying, which is the sourcing mat from the same company really. shaft coupler, 3mm at one end and 5mm the other end. The only problem with this, and I think I may mention it in other videos, is these little grub screws that go at the 5mm end. This is the 3mm end where the shaft is, your drive shaft that goes to propeller. And this is where the motor goes into, right? So it's a coupler. Now you can use just a bit of silicon fuel tubing, and it's adequate because I've used that on a previous boat and it's great. But this is quite nice. The only thing is the 5mm hole is too big, obviously, for the shaft, which is typically around 3.9mm. So what you need to do is make yourself a TPU bush that slots into here, that's thick, that obviously lets the shaft go in, but also just fills out the gap between the 3 and the 5, so a 2mm, approximate 2mm bush wall thickness. And then these grub screws will then put pressure onto that TPU bush onto the shaft. If you try and put the 3mm or 3.9mm shaft directly into that, even though you may try to get these two, 180-degree opposite grub screws equidistant and try to get the shaft in the middle, because they've got points on the end, there's not enough purchase area on the shaft, and it tends to wobble out of position, and vibration then comes in and it'll just shake itself to pieces, and you'll have no luck at all. But by creating a little TPU bush, uh, you'll find, and I've done one sort of here. They're quite easy to make TPU bushes. In fact, it's just easy to go and make one rather than open the ones I've got. But to create a little TPU bush, just go create, select your plane at the bottom when you want to create it, select your circle, click in the middle, it'll latch on, drag it. So we'll say it's 3mm, just hit return. Use your mouse to zoom in. Create another circle. This is your sketch, remember. Drag that out to, we'll say it's 5mm, say, because that's saying it holds 5mm. All right. Finish your sketch. Select where you want to extrude. Extrude. And we'll make that say 8mm. And then, let's get that to home. There you have your bush. And then put a couple of fillets. So select that edge, rotate it around, probably that edge and that edge, and then say fillet, and then say 0.2. There you go. And then click on home. Oh, must have missed that one. So again, select the whole control key, by the way, if you want to select those two edges. F for fillet, 0.2. There you go. And now you've got your bush ready to go. Yeah. So that's all you need to do to create. 8mm is about long enough to go into into that little bush, because it's about, I'd say, it brings it out midpoint, somewhere around there. So that is your drive shaft that goes to the prop. This end goes to your motor, and then with that little bush, you'll find that makes a very snug fit, and will centralize quite nicely and stop. And TPU is strong enough that the grub screws at either side will just put enough pressure on to nip it, and it seems to also cut down any vibrations. So I usually fit the motor, the last thing I do, I'll get the drive shaft aligned. I'll make sure it's spinning freely inside the housing, it's not touching anything. I create another little bush for another TPU bush to go into the actual jet housing. So that is this little thing. Let's just clear this build plate. So I'll just go Control Open. Let's come down to Raster. So this little bit here, again, doesn't have a bearing because where the drive shaft comes out with a propeller at the back, there is it's the hole that's in the back of this. Let's just turn it around so you can see it. There you go. Zoom back out. This hole here is just too big for the drive shaft. So again, you'll create yourself another little bush that goes in here, TPU bush, and then put a bit of grease or oil. Ideally, I'll just put a bit of oil in there at the back end of it. Water will obviously act as a lubricant as well. Create yourself a little bush that goes in there, and that will then house the or home the drive shaft that goes in the back of here. And that, again, you'll get a very smooth, centralized impeller, propeller, I think you would call it, that sits behind this, that goes into this. So that's what I would recommend after multiple iterations of creating this boat in its various forms. Now, the only other thing I've done, again, is I created another, let's have a look, we want to get the hull, two additional bushes, that one that sits here, another TPU bush that sits in there, and if we rotate this thing around, another TPU bush that sits in there, and you'll need those as well. Again, they're not included in the design of this boat, but they're necessary. And the reason why they're necessary is once this starts propelling itself, back pressure builds up inside this duct. So a number of things we've learned is that water will simply flood through into the hull because the back pressure is so high, so intense, because this thing's chucking out an amazing amount of water out the back. You just wouldn't believe how much thrust that this actually, and the the impeller propeller produces. It's phenomenal. And so we couldn't figure out why everything seemed fine in the bathtub and it wasn't leaking, and all of a sudden you get sailing and the thing sinks, virtually fills itself up. And it dawned upon us in the end that with PLA being quite porous, and I had to go and lacquer up the whole outside hull and in here as well, and put 5% infill in the whole hull to prevent water permeating through. The pressure that's trying to come through here is so strong that it will actually burst through quite easily. So create yourself some semi-snug fitting TPU bushes in here. That's just nipping the shaft a little bit. And once you put your lubricant in here, which is typically a graphite grease or something, you just syringe it into here, put your little grub screw or your hex screw into there. Once you pack it out with grease, the grease will go straight through into the shaft here. And these two TPU seals that sit there and there, you'll see a little bit of oozing of the grease coming out, but what happens then is no water will come back through there because the combination of the two TPU seals and the grease will prevent any water coming into the hull. And with a 5% infill, which I'd recommend about a 5% infill, and then get yourself some lacquer. Well, it's not a lacquer, it's a cellulose lacquer. Let's have a look at it. I picked this stuff up, again off good old Amazon. This stuff, crystal clear gloss, really, really good. And I just sprayed the outside of the hull and the inside, obviously the propeller shaft area, and that seals up the hull nicely, really, really nicely. And now I'm seeing no leaks whatsoever. So those things combined, after much ado, have managed to get me a stable boat, because these boats, of course, have no bilge pump. So any water that gets in here is soon going to reach the electronics. Typically, I'm mounting the speed control on the left-hand side. I'm taping it up. You could silicone gun it up, glue gun it up or whatever, but I usually have it up on the side here, velcroed up on this side. The receiver I've typically got velcroed up under there, or you can put it right in the front. But I like to have it on the side wall, just out the way. And if you're using a battery monitor, you could either put that in the front, out the way, or potentially mount it somewhere else. The speed controller sits down here, then the cabling comes back up here, the motor obviously sitting around here somewhere, and the battery sits just behind the bulkhead here, and drops in behind the back of the motor. And the battery I would recommend is this one. And the reason I'd recommend this one, I think it's this one, yeah, it's this one, no, not that one, is that this is the correct width. The thickness of this, no, not the 2200, no, it's 1500 I'm looking for. Just go back there a bit. 1500, let me see if it is this one. Yeah, it must be this one. Just check, it must be 25 millimeters thick. There we go. Let's make sure I get the right one. It has to be 25 millimeters thick across here. Otherwise, it will not sit in snugly behind the back of the motor and up against the bulkhead. So I'd recommend something like that, a nice 1500 11.1 3-cell LiPo with an XT60 on there. It's quite a snug connector, so you shouldn't get too much water. So that's it. That's my last recommendations. Just time to go sailing now. So good luck with your bills.